In this video, we're going to show how when we have similar triangles, we can create ratios to show the relationships between how long the sides are. First, let's start out with the fact that we have line segment AB parallel to line segment DC that's given here. So remember that when we have parallel lines cut by a transversal, we get some congruent angles. For example, these two angles will be alternate interior. So that's right here at angle B, and then up the transversal, angle C. Now, if we look at the other transversal between the two parallel lines, we see that angle A maps onto angle D. So we'll give them both two arcs. So B with C, one arc, D with A, two arcs. And then finally, we know that vertical angles are always congruent. So we can mark those each with 3 arcs and 3 arcs. So from here, we should say that angle A maps onto angle D. Angle B maps onto angle C. And then finally, angle P maps onto angle P. Now we can use that to write our triangle similarity statement. So A maps onto D, B maps onto C, and P maps onto P. So triangle ABP is similar to triangle DCP. Now we can use this same mapping to figure out how to write our ratios. So CD over some line segment. Which line segment corresponds to CD? It's something over on the large triangle. Well, C corresponds to B. So under the C, I'll write B. And D corresponds to A. Like that. So let's see if that makes sense. CD corresponds to BA. And as far as the numerical values go, we know that CD equals 5 and BA equals 15. So that's how that one should be done. You could pause the video now and try the other two. All right. So again, C corresponds with B. So under the C, I'll write B. And P corresponds with P. So under the P, I'll write P. So we're talking about CP and BP. And as far as our values go, we know that CP is 6. And BP, we don't know. We have the variable Y. And in another video, we can show you how to solve for Y, or you might see a pattern emerging. Okay. Finally, PD. So P corresponds to P. And D. D corresponds to A. So let's see if that one makes sense. PD with PA. And numerically, PD is 4, PA is X. So there you have it. That's how you map the coordinates onto each other. In this case, using our relationship from parallel lines cut by a transversal. There were two transversals. Then from there, figuring out what angles map onto each other because they're congruent. Then using the mapping to write the similarity statement, A with D, B with C, and P with P. Finally, to write our ratios, our fractions, CD over something. C corresponded to B, so put B in the denominator under C. And D corresponded to A, so put A underneath D. So we're talking about BA. Then numerically fill in 5 over 15, and so on.